Hi, ladies and gentlemen. Notes 4.6 are on finding quadratic equations. So let's just do a quick review of what we have here. So we've got two parabolas, and we're going to look at all the key information that we have for each one of our parabolas. So the first parabola that we see here says, consider the graph of y equals 2 times x plus 1 squared minus 8. Now, let's write ourselves a reminder of what the equation is for a parabola in vertex form. So it's y equals a times x minus h squared plus k. And let's also remind ourselves that the vertex is going to be h comma k, and that the a value will help us to find our step pattern. So our step pattern is going to be 1a, 3a, 5a, 7a, so on and so forth, 9a, all of that kind of stuff. Okay, so let's take a look at what we have here. It says, consider the graph of y equals 2 times x plus 1 squared minus 8. So the first thing I'm going to do is I'm going to identify what a, h, and k are. So here I'm going to write a equals, h equals, and k equals. Okay, so when I look at this right here, I can see that my a value is 2. I can see that the h value, remember, is always the opposite sign, so it's -1, and the k value is -8. So based on that, I can see that my vertex is going to be, right here it says the vertex is h comma k, so it's going to be -1 comma -8. Okay, now that I've done that, I want to see if the parabola opens up or down. Well, the a value is positive, so since a is positive, we can say that it's going to open up. Okay, so the parabola opens up. And then to find the step pattern, remember it's 1a, 3a, 5a, let's add 7a here, so on and so forth. So, and we'll put ... here. So based on that right here, we can say that our first step is going to be 1 times a, which is 2. So it's going to be 1 times 2, which is 2. The next one is 3 times a, which is 6. So we've got 6. Then we've got 5 times a, which is 10. Then we've got 7 times a, which is 14, so on and so forth. Okay, so now that we've done all of that stuff, we can go ahead and graph out all of our information that we have here. So I'm just going to change the zoom a tiny bit so we can be able to graph out all this information that we have. So the first thing we know is that the vertex is at -1, -8. So I'm going to go to the left 1 and down 8, and this is where my vertex is going to be. And I also know that my axis of symmetry will cut my parabola in half right here. So here's where my vertex will be. And then we know that it's going to open up. Okay, so that means it's going to look something like this as opposed to looking something like this. Okay, now that we've done that, then let's go ahead and use the step pattern to figure out where my points are going to be. So the step pattern is 2. So I'm going to go to the right 1 and up 2. That's 1 point right here. So now that I've done that, I've done the going to the right 1 and up 2. Now I'm going to go to the right 1 and up 6. So to the right 1 and up 6, 1, 2, 3, 4, 5, 6. I've got my point here. And then I'm going to go to the right 1 and up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got my point here. And I don't have enough room to go up 14, so that's sufficient. Now I need to reflect all these points over my axis of symmetry. So since this is 1 to the right of the axis of symmetry, I'm going to go 1 to the left of the axis of symmetry and put it out there. Since this right here is 2 to the right of the axis of symmetry, I'm going to go 2 to the left of the axis of symmetry and put my dot there. And then here, this is 3 to the right of my axis of symmetry, so I'm going to go 3 to the left because, again, it's symmetrical. I'm going to draw a smooth curve to connect my dots. And this right here is my parabola. Okay, now that I've done that, all I need to do is find out what the information is that we have down here. So it says from the graph it can be seen that the zeros are, now don't forget your zeros are where your graph crosses the x-axis. So if I take a look at this right here, I can see that my graph crosses the x-axis at those 2 points. So my zeros, since they're 2 separate points, I need to use my set bracket notation, squiggly brackets. So my answers are -3 and +1, because that's where my zeros are. Okay. The y-intercept is where the graph crosses the y-axis at, and I can see that this is at 0, -6. This is a coordinate, so use regular brackets. The optimal value always happens at the lowest point right here, or the highest point, and it's the y value. So right here, I can see that my optimal value, my lowest point is at -8. So the optimal value is when y equals -8. And my axis of symmetry, which we drew in right here, is going to be, don't forget to write the equation of a line. So I'm going to say that it is x equals 1. And then I'm all set with this question. Okay. So for parabola 2 right here, we're going to consider the graph of y equals -x minus 2 squared plus 4. So same thing, we want to identify each piece of information that we have here. So we're going to say a is -1. We're going to say h is +2 because it's always the opposite sign, and k equals +4. So from the equation it can be seen that the vertex is 2, 4 because it's always hk. The step pattern, the parabola opens, since a is negative, it means it's going to open down, so the parabola opens down. And then the step pattern is 1 times a, which is -1. So 1 times a is -1, 3 times a is -3, 5 times a is -5, 7 times a is -7. So let's go ahead and graph this out right here. So if the vertex is at 2, 4, I'm going to go to the right 2, and I'm going to go up 4. Let me zoom in on, or zoom out on this so you can kind of see everything that we need. So right here, our vertex is at 2, 4, so I'm going to go to 2, 4, and I'm going to put a coordinate there. And now the step pattern, let's draw in our axis of symmetry first of all. The step pattern is -1 first of all, so that means I'm going to go over 1 and down 1. The next one is -3, so I'm going to go over 1 and down 3. The next one is -5, so I'm going to go over 1 and down 5. Now I can reflect these points over the axis of symmetry. So right here I'm going to take this point, and I'm going to, since it's 1 away from the axis of symmetry, I'm going to put a dot 1 away from the axis of symmetry. 2 steps to the axis of symmetry, so when I reflect it, I'm going to take 2 more steps. And then 3 steps to the axis of symmetry, so when I reflect it, I'm going to take 3 more steps. Connect these dots right here. Make sure that you have a nice smooth curve, and then we are good to go for this parabola. So from the graph, it can be seen that we have zeros right here and right here because this is where our parabola is crossing the x-axis. So our zeros are going to be at 0 and at 4. Remember, we want the set notation brackets, okay? Also, the y-intercept happens to be in the same spot as our 0 right here. So our y-intercept is exactly the same. So we're going to say it's 0, 0 because we write it out as a coordinate, okay? The optimal value comes from our vertex, and here this time it's reaching a highest point, and the point that it's reaching is 4. So this right here is our optimal value, so it happens when y equals 4. And then lastly, our axis of symmetry is this line that you already drew, and the equation of this line is x equals 2 because it crosses through the x-axis at 2. Okay, so that's just some review on how to do this, to do these graphs right here. Now what we're going to do is we are going to find the equations of quadratic relations in the format, in the vertex form. So let's write down the vertex form again. So it's y equals a times x minus h squared plus k. Okay, so for any of the questions that I will be giving you for this, I'll always give you the vertex. So find the equation of a quadratic relation. This is how we're going to do it. First thing we're going to do is we're going to take the vertex. So we're going to use the vertex and any other point that's not the vertex to find A. And the A is going to tell us, remember, it tells us either the vertical stretch or the vertical compression. And once I know what A is, if I know the vertex, I already know what H and K are, I have my equation. So lastly, I'm going to write the relation in vertex form. And again, vertex form is y equals A times x minus h squared plus k, using the vertex and the value of A. So let's go ahead and try this out. So if I take a look at this graph right here, I can see that I have a vertex right here. So my vertex is at the point -1, 2. So right here, I can see that H is going to be -1, because remember, your vertex is always going to happen at H, comma K. So I know H is -1, and I know that K is 2. So when I take a look at this right here, I can see that my equation, which starts with y equals A times x minus h squared plus k, I can plug in all of this information here. So I'm going to have y equals A times x. Now remember, this minus h means we're going to do the opposite sign of whatever h is. So if h is -1, then we're going to do minus -1, or the opposite of -1 is +1. So we're going to write +1, okay? And then I'm going to copy down the squared. And then right here, the k value is 2, so I'm going to write down +2. Okay? Now that I've done that, the next thing that I need to do is plug in a point to figure out what our A value is going to be. So let's rewrite this here. Y equals A times x plus 1 squared plus 2. And let's look at our graph and find another point. We can choose any point we want. So I see here that this is a nice easy point right here. My y-intercept is at 0, 3. Okay? And don't forget that 0 is always the x value, or the first number is always your x value, and the second number is always your y value. So here, instead of y, I can replace it with this number right here, which is 3. So I'm going to say 3 equals A times, for x, I can just replace it with this 0. And then I'm going to write +1, and then I'm going to copy everything else down, squared, and then I've got +2 right here. Now I'm just going to try to solve for A. So this is what I need to do. I'm going to follow order of operations first, and I see that I have brackets. So I'm going to figure out what this number in the brackets is. So I end up getting 3 equals, I'm just going to copy everything down. So copy the 3 down, the equal sign, the A down. 0 plus 1 is just 1. Copy the squared down, and then the +2. Then I'm going to square this 1 right here. So when I square 1, it just means 1 times 1, which is 1. So I get 3 equals A times 1 plus 2. Now, A times 1 is just 1A, or just A. So I can say 3 equals A plus 2. Subtract the 2 from both sides to get the A alone, because the opposite of adding is subtracting. And I end up getting A equals 1. Now that I've done that, I can go back to this equation right here, and I now know that A is going to be equal to 1. So all I have to do is plug in that 1 here instead. So this is going to say y equals 1 times x plus 1 squared, and then just +2. And this is my equation for this parabola right here. Okay? Now I don't have to put the 1 there, but it's totally okay to put it there. Okay, so let's take a look at our next one that we have here. So the same thing. The first thing I want to do is identify what my vertex is. So when I look right here, this is my vertex. So I know that my vertex is going to be 1, -4. So based on that, I can see that h is going to be 1 and that k is going to be -4. So here I'm going to use y equals A times x minus 1 squared
plus k. Okay? Now that I've written that out, what I want to do is I want to fill in my h and my k values. So in order for me to be able to do that, it's going to look like this. So y stays the same, a stays the same. Here I'm going to say x, and since h is positive 1, I'm going to write minus 1 here. So I apologize right here. This was originally supposed to say minus h squared. I just was going to copy down the original equation that we used, the vertex form. Now when I plug in my number, this is going to say minus 1 squared, and then k is negative 4, so here I'm going to write minus 4. Okay, now I'm going to choose any point I want on my graph, and I'm going to plug it in to solve for a. So right here, the point that I'm going to choose is this one right here, just because it's nice and easy. It's up to you, whatever point you want to plug in. So right here, I can see that this point is 0, negative 6. And since x goes first in my coordinate, x is 0, and y is negative 6. So I'm going to plug in 0, negative 6. So let me go ahead and rewrite the equation. Y equals a times x minus 1 squared minus 4. And instead of instead of y here, I'm going to plug in negative 6. So I'm going to say negative 6 equals a times, instead of x, I'm going to plug in 0. And then I'm going to have minus 1. I'm going to square that, and then I'm going to write minus 4. To follow order of operations, and I'm going to figure out what these numbers are. So here in my brackets, I have 0 minus 1, which is negative 1. So this ends up being negative 1, and then I still have to square it, minus 4, and then I'm going to copy down the a, and I'm going to copy down the negative 6. Okay, now I need to square this negative 1, and negative 1 squared means negative 1 times negative 1, which is positive 1. So I end up getting negative 6 is equal to a times positive 1 minus 4. Well, a times 1 is just a, so I get negative 6 equals a minus 4. Okay, so the last thing that I need to do right now is I need to add 4 to both sides to get this a alone. And here I end up getting a equals negative 2. So now that I know what a is, I can plug it in for this a right here. So my equation is going to say y equals, if a is negative 2 here, I can say negative 2 times x minus 1 squared, and then I've got minus 4. And that's my answer. Okay, so let's take a look at our last question right here. This time we don't have a graph, but we do have our information that we need. So we know our vertex is 4, negative 2. So we know that h is 4, and we know that k equals negative 2. So here I'm going to say y equals a times x minus h squared plus k. But I know that h is 4, so I'm going to write minus 4. Again, it's always the opposite sign, squared, plus k, and k is negative 2, so I'm actually going to write minus 2 right here. So I'm going to write minus 2, and then I'm going to plug in my information here. So x is 0, y is 2. So here I'm going to plug in 2 right here, equals a times 0 minus 4 squared minus 2. So right here, I end up getting 2 equals a times, I'm going to evaluate 0 minus 4 is negative 4. So I get negative 4, and then I still have to square it, and then I'm going to write minus 2. Okay, so up here, what I end up getting here, I'm going to evaluate what this negative 4 is when I square it. So negative 4 times negative 4 is 16. So this ends up being right here. I know that this is 16 right here. So I'm going to write down 2 equals a times 16 minus 2. Okay, so now right here I get 2 equals, instead of a times 16, I'm going to say 16a minus 2. Now I'm just going to solve my equation. So I'm going to add 2 to both sides. Get 4 equals 16a. These 2's cancel out. To get this a alone, I'm going to divide both sides by 16. So I end up getting a equals 4 over 16. So 4 divided by 16 is equal to 0.25. So here I end up getting 0.25 as my a. So now the last thing I need to do is, if I know that my equation is y equals a times x minus 4 squared plus, or minus 2, excuse me, and we know that a is 0.25, we can say here y equals, instead of a here, we can use 0.25 times x minus 4 squared minus 2, and that's my answer. Okay, so we figured out how to do all of this stuff using algebra. In class, we're going to spend a little bit of time figuring out how to find these answers using Desmos. So we'll do that probably in the next couple of days, but you still need to show your work out using algebra on your problem sets. All right, let me know if you have any questions. Have a great day. Bye.